Section 8.2 the test for the mean. So the test mean when the sigma is unknown in this case, okay? Sigma is unknown. So using the z-test. So when the sigma is unknown, we are using the another test. The statistical test is called the z-test for the mean. The z-test is we always for mean. Is for the when the sigma, which is a population standard deviation, is known. So we do not know about the population standard deviation, we cannot use a z-test. So this is the different test which is discussed in the next sections. Okay. So formula for the test statistic. So the test statistic, we are using these formulas. Okay. So we has observed value, subtract the expected value, where the observed value is a statistic such as a sample mean, and then compute it from the sample data, and the expected value from the hypothesis population statistics such as the population mean is expected if the null hypothesis is true. The denominator is the standard error of the statistic being tested, such as the standard error of the mean. So thus the z-test is a statistical test for the mean of the population. So it is appropriate the sample is the random sample. So that's neither n is greater equal to 30 or normally distributed. And then sigma must be the knowns. Okay, so we are using these formulas. So x of bar means a sample mean, mu is a hypothesis of population mean, and then sigma is the population standard deviation, and n is going to be sample size. The first step for the testing hypothesis to check that the assumption has been met during this class assumption stated in the exercises. So recall the 5 steps to solving the hypothesis testing problem. So first one, we need to state the null and alternative hypothesis, and then identify the claim. In number 2, define the critical value. And then number 3, test statistic. And number 4, we need to make a decision, rejected or not rejected null hypothesis, and summarize the results. So take the 5 steps. So sample statistic may be lower or higher than a hypothesis parameter without being significantly low or higher. In other words, the difference may be due to a chance. And however, there is a still chance the type 2 error or not rejecting a hypothesis when it is a false. So when the difference is statistically significant, no hypothesis is rejected, and significance is the chance of making type of 1 error. The researcher has set. So keep in mind that when a null hypothesis is rejected, there's a chance to making type 1 error and rejected null hypothesis that is true. So when a null hypothesis is not rejected, you may not accept it true. So there's not enough evidence to say that it is a false. So when a null hypothesis is rejected, you may not say it is a false. There is, however, enough evidence to conclude it is a false. All right, so let's look at the problems. Okay, so age of the medical doctors. So we talked about that a little bit earlier too. So a researcher believes that the mean age of the medical doctor in the large hospital system is older than the average age of the doctor in the United States, which is 46. Assume the population standard deviation is 4.2 years. The random sample of the 30 doctors from the system is selected, and then the mean age of the sample is 48.6. And then the test claimed that alpha equal to 0.05. So we need to actually state this as before we proceed the work. Okay, I want to say that we need to find the x bar. So I want to say it's about 48.6, and then mu is, they say, 46, and then sigma population division is 4.2, and then the sample is going to be the 30 doctors. Okay, all right. So step 1, no hypothesis. Okay, so we are using mu, which is 46, and h of 1, which is mu, is now the greater than 46, which is this because the claim said that the larger hospital is getting older than the average of the doctor in the United States. So this is I want to say this is a claim. Alternative hypothesis is a claim. Alright, step 2, now we have to find the alpha critical value, which is 0.05. And also, it's a right tail because it's say greater. And so, which means on the right tail, so which is we have to can make the normal curve, which is about here. So this is the right tail. So area is actually 0.05. So as a z-score, you can see is going to be g sub 0.05, which will come out as 1.65. So this is actually the important number to check. All right, now step 3. We need to find the test statistic, which is the test value, which is a z is this time. The formula is x bar minus mu of sigma over square root of n. Plug it in. So 48.6 subtract 46 and divide by sigma 4.2 and divide by 30. So compute this, you get the 3.39. Now you need to actually put the 3.39 in the normal curve. So as you notice, this is 3.39 is about here, right? So this is 3.39. So it's in the critical region. Okay, so in step 4, since 3.39 is greater than the critical value, which is 1.645. So the decision is to reject the null hypothesis. In this step, we can state the conclusion. So we can say there is enough evidence to support the claim that the average age of doctor in the system is greater than the national average. That's our average age of the 46. Okay, all right. Okay, so that's how you use a hypothesis test. But remember, okay, when the test falls in the critical region, your decision to reject the null hypothesis indicated the difference is not likely have been due to the chance. So remember also, when the test statistic falls in the non-critical region, the decision not to reject the null hypothesis indicates that the difference is most likely due to the chance. All right, let's go to the next page. All right, in the next page, we got some work to do to get this out, okay? So let's read the questions first. The average 1-year-old of both genders is a 29 inches tall. And the random sample is a 30 in 1-year-old and the large daycare franchise results in the following sample of the height. Can it be concluded that the average height of the differ from the 29 inches at a significant level of the 0.05? So first of all, the x bar, you're going to actually add it all together and divide by, okay, which is divide by 30. You should get the 29.45. So as a null hypothesis, it's going to be the mu is going to be 29, okay, because mu is 29 and sigma is 2.61, and then the n is going to be 31-year-old, okay. All right, 29. And then for the each of 0, no hypothesis. So, and then alternative hypothesis is going to be the mu is not same as 29. So it says a different. So I want to say this is a claim. Alright, so now in second step, we have to find the critical value, which is alpha 0.05, and this is actually the not equal to, so we have to say 2 tail. Which means we have to use the alpha over 2, which is 0.05 divided by 2, 0.025. So in the normal curve, and then I want to say area in here in the critical region is 0.025, and this side is a 0.025. So g squares of the 0.025 as here, and then the z scores we got the here. So actually this is going to be the other side, okay? So it's going to be the 1.96 if you use a D table. So this is same as a negative 1.96. Okay, so now that's what you need to remember. All right, this is an important number to use as a z-score. Now we have to find the test statistic, which is a z-score is x bar minus mu of sigma over square root of n. X bar is 29.45. Subtract the 29 over 2.61 divided by 30. And then I got 0.9443. 0.9443 is actually the zeros here, so about here. Less than the 1.96, right? So it's going to be, I want to say 0.94. So 0.94 in here. So now, the z-score is in the non-critical region. Which means we should not reject the null hypothesis. Which means there is not enough evidence to support the claim, which is different, that the average height of 1 year old differs from 29 inches. So which is just still stays as the 29 inches. All right, now I want to talk about p-value, which is we're using the traditional method, okay? So which is a classical method, and then we also can use the p-value method. So p-value that you need to find the probability, which is the area on the table, to compare with the alpha, which is a critical value, and then you decided you're gonna reject it or not reject it. So if p-value is less than or equal to alpha, we reject the null hypothesis. P-value is greater than alpha, and then we do not reject the null hypothesis. Okay, so notice that the alpha is chosen for the researcher before the statistical test is conducted, while the p-value is computed after the sample mean test statistic has been found. So for the z-test, using a table E, appendix A, to find the p-value, first to find the area under the standard normal distribution curve corresponding to the z-test value. For the left-tail test, use the area given in the table, and for the right tail, and use the 1 minus area given in the table to find the p-value for the two tail, and the double area, and then find the one tail. However, the calculator and the computer software that calculate the p-value and then calculates the actual p-value. So the subtracting, doubling is not needed. Okay, so if you use a graphing calculator or other stuff as a technology. So procedure table solving the hypothesis testing problem using the p-value method. Okay, step 1. So we gotta do state the null or alternative hypothesis and identify the claim. Step 2, test the statistic, find it, and then find the p-value from the test statistic, and then we need to make a decision for the reject or do not reject the null hypothesis and summarize results. So guideline for the p-value. If the p-value less than equal to 0.01, reject the null hypothesis. The difference is highly significant. P-value is greater than 0.01, but the p-value is less than 0.05. The reject the null hypothesis difference is significant. And p-value is greater 0.05, but p-value is less than or equal to 0.10. Consider the consequences of the type 1 error before the rejecting the null hypothesis. And then p-value is greater than 0.10. Do not reject the null hypothesis. The difference is not that significant. All right, so let's look at the number 3 using the p-value this time, okay? So this is not bad, actually. I like it. So first of all, we need to find so let's read the questions, okay? A researcher claimed that the yearly consumption of the soft drinks per person is more than 52 gallons. Oh, that's a lot. In a sample of the 50 randomly selected people, the mean of the yearly consumption was 53.7 gallons, which is more than 52. So population standard deviation is 3.5 gallons. And so find the p-value for the test, and you maybe use the technology or the table. And is there evidence to support the claim at the alpha equal to 0.05 and use the p-value method, okay? So first of all, we still need to find the test statistics. So I want to say x bar is, and here is a 53.7, and then mu is 52, and then sigma is 3.5. And then the n equal to 50 selected people, okay? So state the null hypothesis, which is mu is 52, and then x of 1 alternate hypothesis mu is going to be greater than 52. Test alpha could go the value 0.05, but this is the right tail. So the final test statistic, which is a z equal to, so x bar minus mu over sigma over square root of n, which is 53.7 subtract 52 equal to sigma 3.5 over square root of 50. And then I'm getting as 3.43. All right, so now this is a right tail. So we need to actually get to the z sub alpha, which is a z sub 0.05. So in order to get that, this is a right tail. So which is zeros right here, okay? So this is a z sub 0.05, and then this is actually the 0.05. So that's actually the alpha, okay? And then we want to know where is the 3.43. So 3.43, okay? So I need you to, so this is actually the, we need to find the of the closer 3.43. So if you go to the table, and then for the 3.43, so which means it's from the 3.4 and then 3 right here. So this is the numbers. So 0.997, okay? So I'll go back to our problem, which means the area, which is gonna be the, so the but the area is actually the, I don't know, it's gonna be here or there, okay? We have to kind of see. So we have the area was p is 0.997, which means in order to get this value, we have to make it becomes 0.003. So this is actually the p-value. Okay, So now we do is we need to compare the p-value with the alpha. So p-value is a 0.003 and then alpha is a 0.05. Is it less than equal to that? So it is, right? So this works, right? So p-value is less than equal to alpha, which means the decision has to be reject the null hypothesis. So even though there's no significant level given, and then the p-value is so small, so the sample is significantly different. So that means how do you conclude that? There is sufficient evidence to support the researchers' claim. So what is the claim was? The yearly consumption of the soft drinks per person is more than 52 gallons. Okay, so yeah, so people drink the more than the 52 gallons a year. Oh, that's a lot, right? Okay, let's go to the next problem. A researcher claimed that the average wind speed in a certain city is 8 miles per hour. And the sample of the 32 days has average wind speed was 8.2 miles per hour. So the standard deviation is the population of 0.6 per hour at the alpha equal to 0.05 is enough evidence to reject the claim. Use the p-values. Okay, so let's try it again. Okay, so in here f bar is 8.2, and then the mu is 8, and then the sigma is 0.6, and then the n equal to the how many days? 32 days. Okay. Alright, so no hypothesis. Okay, so this is a mu is 8, but it didn't say that the greater or less, it just looks like a different, right? So I want to say mu is not equal to 8. Okay, so 2 tail. So alpha equal to 0.05, but since it's a 2 tail, we have to find the alpha over 2, which is 0.05 divided by 2. So we are using 0.025. Okay, so the test statistic, which is a z equal to x bar minus mu over sigma over square root of n, to plug it in, 8.2 minus 8 over 0.6 over square root of 32, I get the 1.89. Now in order to find the 1.89, which is we have to actually for the two-tail test for the 0.05, which is about here to here, right? So this is 0.025, and this is another 0.025 because it's two-tail. So, and then what we're gonna have here is we have to make the 1.98 to find what the 1.98 to get how much it is. So let's look at the table. So 1.98, 1.89. So 1.8 all the way to up to here. So it's about 0.7 and 0.9706. So z-score for this case is, okay, which is we have to say 1 minus of the 0.9706, which is a 1.89, which is going to be the 0.0294. So this is actually the area, okay? All right, so in order to find it, the is going to be 2 times of the area we found, which is 0.0294, which is a 0.0588. Now compare with alpha. But alpha was 0.05. So is that statement is true? I don't think so, right? So it's not, right? That means we do not reject the null hypothesis, which means there is not enough evidence to reject the claim, which is not equal to that the average wind speed is 8 miles per hour. Alright, so that's how you use for the Z-score to do the test statistic. Thank you for listening.